All right, let's go. Hey, if you're not subscribed, please subscribe. Download the free PDF. It's in English y Espanol. Give us a thumbs up. Do some math with people you love. Come on back, grab some popcorn, and see how you done. All right, now we're going to write equations in standard form. Standard form, that's AX plus BY equals C. So AX plus BY equals C. This is a rate. This is also a rate. And this is your total. The solutions are the ordered pairs, X, comma, Y. All right, so A, B, and C are numbers. They're called parameters. And the solutions that you graph are the X and the Y. Okay, let's do it. Tickets to the movies are $5 per child. Hey, there's a rate. There's a rate. I'm going to highlight that. And $10 per adult. There's another rate. And we should have two rates when we're talking about writing an equation in standard form. Last weekend, a group of people went to see the latest math adventure. Who plotted the points? Ooh, it's a thriller. The total cost was $60. There's that total right there that we're talking about. Okay, let's do it. Assign variables. Well, I'm going to assign variables that make sense. So I'm going to let C equal the number of children that attended the movie. And I'm going to let A be the number of adults that attended the movie. Okay, that's not bad. That's not bad. Well, what's the first rate? The first rate is $5 per child. The second rate is $10 per adult. And the total was $60. Okay, I'm going to use my variables, right? And I'm going to write an equation. So, my equation is going to be, one thing I notice right away is, notice my input value is X, right? And that's the first column. My output value is Y, so that's going to be children. So when I write this, I'm going to put my A term first and my C term second. So it's $10 per adult plus $5 per child, and we had a total of $60. Okay, let's fill in this table. First thing I'm going to do is I'm going to let adults be 0. So 10 times 0 plus 5C equals 60. That goes to 0. 5C equals 60. Divide by 5, you get 12 adults, 12 children. Now let 10 be 1. I want to know how many children can go if one adult attended. That's 10. Subtract 10 from both sides. Divide both sides by 5. So 10 children. Notice there's kind of a pattern. Every time we increase by one adult, we decrease by 2 children. So increase by 1, decrease by 2. Increase by 1, decrease by 2. Increase by 1, decrease by 2. Boom. I'm going to make this a 6, and now we have 0. What happens at 7, though? It's a good question. What happens at 7? Well, if I have 7 adults that attend, then that would cost me $70. Hey, that's more than we spent, so that's not possible. So this is not a possible income or input. Not a possible input. All right, so we're very restricted about our inputs and our outputs. Would the graph of this function be continuous or non-continuous? Well, you can't have a half of an adult and you can't have a half of a child. So therefore, this is non-continuous. Okay, let's keep going. Notice my adults is the first column, so that's going to be my x-axis. Adults, and I'm going to do increments of 1. So 1, 2, 3, 4, 5, 6, 7, 8. I know it doesn't take very much, but we're going by increments of 1, so we got what we got. Now I'm going to let this axis be children. And I'm going to do increments of 1 is there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Okay, let's plot some points. So the first point is 0, 12. So if 0 adults show up, then 12 children do. If 1 adult goes, then 10 children. If 2 adults, then 8 children. 3 adults is 6 children. 4 adults, 4 children. 5 adults, 2 children. 6 adults, no children. And that really represents all of the solutions. There's no point in me graphing anything in between because nothing in between makes sense. You cannot have 2.5 children. You can't have 4.5 or 4 3/4 of an adult or 4.8 adults. So that is the graph. All right, determine the maximum number of adults take a spot if no children went. Well, the max number of adults if no children went is 6. So 6 tickets. All right, that's great. Let's do it again. Okay. Use the following information to answer the question. Okay. A student at CHS wants to earn a total of $150. Okay, that's important because that represents my total. So my total is 150. So I'm going to highlight that because that's important. What do? They want to donate to the local homeless shelter. That's very noble. All the ingredients were donated. They want to sell large cookies and cupcakes. Okay. They will sell the goodies for $2 per large cookie. Ooh, that's a good deal. And $3 per cupcake. Ooh, I'm salivating here. Okay. Let's assign some variables. I'm going to let L equal large cookies. And I'm going to let C equal cupcakes. All right, what's the first rate? Well, the first rate is $2 per cookie. And the second rate is $3 per cupcake. And the total, well, that's $150 that this young person earned. Nice job. Okay, let's make a table. Oh, no, first we've got to write an equation. So notice cookies is my input variable, right? Because that's the first label that's the first column. The second column is the output, the cupcakes, all right? So cookies are first. So 2 times every large cookie plus 3 times every cupcake equals 150. And this will give us all the possible combinations. We're going to include 5 inputs and 5 outputs. That's what it's asking us to do. So 0, I'm going to find these values first. So if I have 0 cookies sold, then that means this goes to 0, and I just divide 150 by 3. That gives me 50. So if 0 cookies were sold, 50 cupcakes were sold. Now, if 0 cupcakes were sold, then I take 150 divided by 2, and that'll give me the total number of large cookies sold, 75. Okay, now I got to pick 3 ordered pairs in the middle. So I'm going to pick 20, 40, 60. I just picked them. I really just randomly picked them. They're nice numbers to work with, so I like that. Okay, so now what I'm going to do is I'm going to substitute in 20 for large cookies because I want to know how many cupcakes did I sell if I sold 20 large cookies. There's that. Subtract 40. This may not work. This doesn't work, and I'm going to show you why. Okay, I'm going to show you why. 110 divided by 3. That's not a possible value. I can't have a decimal amount of cupcakes sold, right? So that's not possible. So I got to think this through. I have to use increments. I have to use numbers that are multiples of 3. So I'm going to go back and I'm going to make this a 15 and I'm going to make this a 45. They got to be numbers that divide by 3 evenly. Okay, let's do it now. See how I did. So I'm going to change that to a 15. That's now a 30. Subtract 30. That's 120. Now we got it. Okay, so we really got to think about what we can put in and out on this one. Okay, that's 40. That was tricky. Okay, now I'm going to do it again. This time I'm going to input 45. So 45 large cookies. 2 times 45 is 90. Subtract 90. Divide by 3. And that's 20. Okay, now I'm going to put in 60. I'm going to do this one using my calculator. So I'm going to do 2 times 60. That's 120. I'm going to do 150 minus 120. That's 30. I'm going to divide that by 3. That's 10. Okay, that was tricky. All right, continuous or non-continuous? This is non-continuous because I'm not going to sell half of a cupcake or half of a cookie. So if taking half of something doesn't make sense, then it's non-continuous. Okay, cookies is going to go on my horizontal axis. That's right here. Cupcakes are going to go on my vertical axis. All right, I got to get up to 50 cupcakes, so I'm going to do increments of 5. I got to get up to 75 cookies. If I did increments of 5, that would be 15. Okay, I'll do it. I could have done increments of 10 too, but I like 5. So there's 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay, there's that. Now I'm going to go to that was cupcakes. That was cookies, my bad. Now I'm going to go to cupcakes. I'm going to do increments of 5 there too. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, I like to use the majority of my graph, more than half if possible. All right, let's plot some points. 0, 50. 0 cookies, 50 cupcakes. 15. Well, here's 15 and 40. Boom. 45, 20. 45 and 20. 60 and 10. And then 75 and 0 right there. Okay, now remember, this is continuous. This is non-continuous. So when I graph this, I do not want to make solid line. I want to make a line that's a bunch of ordered pairs, like so. And they got to be ordered pairs that make sense in the context of the problem. But I just want the reader to know what I'm doing. Another way you can do it is just make it kind of dashed. Okay, just show the reader that there's gaps. That's what we're trying to do, is just show there's gaps, and that shows that it's non-continuous. All right, how many large cookies were sold if there was a total of 30 cupcakes sold? Well, I got to go up to the original equation. So the original equation is 2L plus 2C equals 150. Notice they say there were 150 cupcakes. I'm sorry, there was a total of 30 cupcakes sold. And they want to know how many large cookies. So make sure you're reading the question. So, cupcakes, right there, that's 60. Subtract 60 and you get 90. Divide 90 by 2 and you get 45. 45 large cookies. Okay, how many cupcakes were sold if there was a total of 45 large cookies? All right, we're going to go to the equation. They gave me large cookies, so I'm going to put 42 in. They want to know how many cupcakes. That's at 150. Multiply that, that's 84. Subtract 84, and you get 66. Divide by 2, and you get 33. So 33 cupcakes. Is it possible to reach a target of exactly 150 if 33 cupcakes were sold? Well, let's find out. It has to go into it evenly if it does. So 33 cupcakes. That would be, oh, I forgot the 3. I don't know what to do. I'm going to go like this. Womb, womb. Ooh, well done, well done. That's 99. Uh-oh. Subtract 99. Divide 51 by 2, and you get 25.5. No, it is not. No, because you cannot sell 0.5 of a cookie. Okay? Okay, let's keep going. We're doing great. Let's keep going. All right, use the following. In my pocket, I have $1 and $5 bills. I have a total of $50. So that's my total. All right. Write an equation to represent the possible combinations of $1 bills and $5 bills. Okay. So we have $1 bills and $5 bills. This is going to be a little tricky, I think. I think this is going to be a little tricky. Okay, so assign variables. I don't want to use the 0 as a variable O as a variable because it looks like a 0. So I'm going to use N for $1 bills. And I'm going to use F for $5 bills. All right, what's my rate? How much is a $1 bill worth? Well, it's worth $1 per bill. How much is a $5 bill worth? Well, that's $5 per bill. And what was my total? $50. Okay, let's complete the table. Look, if I have 0 $1 bills, well, first let's write an equation. $1 times every $1 bill is going to give me a total of money of ones, plus $5 for every $5 bill is going to give me a total for $5 bills, and I want a total of 50 with those two combined. Okay, let's now fill in a table. If I have 0 $1 bills, that means this is going to be true. Divide both sides by 5, and you get 10. If I have 0 $5 bills, well, then I got to have 50. Now, I know that I'm going to have to divide by 5 every time I pick an input. This is my input, this is my output. So I'm going to do numbers that are divisible by 5. That's what I want to do here, numbers that are divisible by 5. So I'm going to do 15, 30, and 45. I just chose those. Just chose them. All right, if I have 15 $1 bills, isn't that $35? So 50 minus 35 is 15. So how many times is 5 going to 15? Sorry, take that back. If I have 15 $1 bills, that's 15. 35 is correct. So then I have 35 divided by 5. That's 7. So if I have 15 $1 bills, I must have 7 $5 bills. $15, $35 equals a total of 50. If I have $31 bills, that means I have $20 of 5s. 20 divided by 5 is 4. If I have 45 $1 bills, that means I only have $5 left. 5 goes into 5 once. Okay, that's not bad. This is going to be non-continuous because we don't have coins. So we don't have 0.25, we don't have a quarter, We don't have 0.05 and nickel. A lot of these tend to be non-continuous if you haven't noticed. Okay, now let's graph it. We got $1 bills here. I am not going to do increments of 1. That's too many. I'm going to do increments of 5. And I have $5 bills. These increments are going to be different, and that's okay as long as I stay consistent on the axis. Those are going to be increments of 1. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Boom. Now I'm going to go here. 0. Increments of 1, but remember, everything represents one $5 bill, right? So this is, again, going to be kind of tricky. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's plot some points. 0 $1 bills, 10 $5 bills. Right you up. 15 $1 bills, 7 $5 bills, 30 $1 bills, 4 $5 bills, 4, 5 $1 bills, 1, and then 50 is 0. Okay, let's graph it. Remember, it's non-continuous, so I'm going to do a dashed line, boom, 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 ba-doom, boom, boom. That's it. Okay, how many $1 bills are in my pocket if there are 6 $5 bills? Well, heck, we can figure this out. 6 $5 bills, that equals $30. Well, what's 50 minus 30? That's 20. So you would have 20 $1 bills. Okay. How many $5 bills are in my pocket if there are 10 ones? Well, 10 ones equal $10. So take the total amount in your pocket, subtract 10, that would give you 40. So 40 divided by 5, that's 8, because every $5 bill is worth $5. So 8 $5 bills. Is it possible to reach exact amount of $50 if I have 35 $1 bills? Well, let's find out. 35 $1 bills is $35. So if I subtract 35 from 50, that means I need to have $15 worth of 5s. Does 5 go into 15 evenly? Yes. I would have 3 $5 bills. Let's go. This is great. 1 page to go. You're doing amazing. Keep it up. All right. Given the graph, identify the slope. Well, the slope is rise over run. So from here to here, rise over run. 1, 2, 3. So I rise 3. 1, 2, 3, 4. Run 4. So my slope is 3 over 4. Identify the y-intercept. The y-intercept is where you cross the y-axis. It's right there. That looks like the number 1 to me. Write that as an ordered pair. Right? X is 0. Y is 1. Okay, let's write the model. Notice our output variable is y. Slope plus the initial value, or the y-intercept. Boom! That's done. What is the name of this function? Well, the name of this function is the letter out in front. So the name of this function is h. What's the input variable? Well, the input variable is right there. It's h of x. So name of the input variable. The input variable is also there. The rule is all of this. The rule changes the input to the output value. All right, what's the slope of this? Y equals mx plus b. So -3 or -3 over 1. What is the y-intercept, or initial value? Well, that's right there. Write that as an ordered pair. That's the b. Okay, we're in good shape. I'm going to use my straight edge to draw an x and a y axis. There's my x-axis right here. And there is my y-axis right here. I'm going to label them because they say label them. Okay. Now I'm going to plot my 0, 5. 0, 5 is my y-intercept. 1, 2, 3, 4, 5 right there. Now I'm going to go down 3 over 1. So down 3 over 1. Over 1. These represent solutions. Now you can have fractional inputs and outputs as solutions for generic graphs. So we're good. We just now need to graph it. And I'm going to make it continuous because it's not a word problem. Inputs and outputs can be all real numbers. Make sure you drive it through. Put arrows on the ends. Chicka-ching, chicka-choo. And that's done. That was fun. Solve the equation. Holy Toledo, Batgirl. Okay, first thing I got to do is I got to distribute 3x plus 6. That's what I get when I do that. Minus 5x equals 4x. This is a tricky distribution. You're distributing the minus through. It's like a minus 1. So minus 2x, because minus times a plus is a minus. Minus times a plus is a minus. Combine your like terms. They're on the same side of the equal symbol. 3 minus 5 is negative 2. 4 minus 2 is 2. Now I'm going to do inverse operations. Move your variables to the left. That gives me negative 4x plus 6 equals negative 14. Subtract 6. I get negative 4x equals negative 20. One more move. Undo multiplication with division. X equals 5. Let's go! All right, kiddos, well done. Good job. Now that you've done your work, now you can play a little bit, but make sure you always get your work done first before you play. That's what builds character. That's what makes you stronger, and that's what's going to build success. All right, you're wonderful. Look forward to seeing you soon. Bye now.